just like to say thank you for everyone who's sent me circuit diagrams and sent me sort of tips on trying to get scale linearity right on this Selina. What I'm doing this evening is, as you see here, I've removed the tuning gang drum. You can see there, I've removed the drum and it's now out of the way, so I'm going to better remove the board. For those who are interested, it looks like this is the circuit diagrams here, and it's showing here the lists of all the the component changes. See, quite significant changes, you know. So I'm going to remove it from the board and strip all the components down. So this is going to be a bit of a tedious part of the program, getting this all apart. But let's have a go. So basically, I've taken the drum off, twisted it 90 degrees to wrap the string round together, and then just taped it to the radio, so it's out of the way. And now I'm just going to do what I normally do, is take a photograph so there's no chance of getting any of the wires in the wrong place, and we're going to strip the board out and totally recap the whole thing, because it's obviously crap caps are a load of junk, and they either drifted or they were never any good in the first place. It looks to me that they've made such a change that there's obviously there's been a problem from the word go, I would say. So just get a photograph of that. Okay, let's start removing some of these old capacitors. Now, a lot of these are ceramic, and I've probably got them, but some of them I might have to actually order in. I've got quite a selection of small ceramics, but first of all, remove the wiring. It shouldn't take too long. The medium wave performance, as I said, is pretty good. What I'm going to do is once I get to take some of these caps out, we'll test them on the LCR and see how far out they actually are, because it'd be interesting to see. People say that the caps fail on these, and I've never heard of a ceramic capacitor going faulty really, so I'm sure there's a first time for everything. It's not obviously, there's always an exception to the rule. Must be the supply line to it, the red wire. That's going to be a bit of a sod to get off because it's got a bit of heat shrink around it or something. Connect. Yeah, that's the, looks like the supply back from the power supply. Okay. One thing I have noticed is the tuning capacitor on here is really quite sloppy, and that does actually make it quite difficult to tune, because the shaft's got a lot of play in it. When you tune, you get it to the right place and let go, and it sort of springs back slightly, and you have to sort of overcorrect the tuning slightly to get the position you want, which is, I don't think there's a lot we can be able to do about it. I've tried to adjust the see if I can get any of the free play out, but it's not looking like it's possible really. It's not going to be very easy to do. It really needs a new tuning capacitor, but they're probably all much the same. They've probably all got the same free play in them as well. So, and the screws are all locked in sort of like a paint. Sort of like almost like a thread lock, but like a paint. Sort of looks like white gloss paint, which is probably what it actually is. So there's the screws out. So this board loose. Probably not. So maybe something else holding it in place. I'm hoping I don't have to take the whole board off the whole board off the metal backplate because that's going to be a bit of a pain to get to. That undoes there. If you can hear a baby scream in the background, it's the next door neighbour's child. It seems to scream all the time when it needs attention. So there's nothing nasty or untoward going on. So that's the there we go, that little plastic bush. That's the plastic bush that holds the top cover on. So there's there's the board out. So there's the board. So we can actually get access to it now. So basically, when the camera's decided it's going to actually focus, thank you. So we'll strip that down, and the next step will be to replace all those caps that are obviously a bit crummy. But also, I think what we'll do first is we'll do some checks. So let's power the LCR up and take out one at random. Now, one of the ones it suggests you take out and change is a series capacitor on the you can see this. So we've got a couple of. Let's get this one of the capacitors. It tells you to change one circuit diagram. That's the circuit we want. Is a series. This to me looks like the local oscillator. This is a series capacitor, and someone said to me, "Is there a series capacitor?" I said, "No, there's a parallel." Well, actually, there's a parallel and a series, so I stand corrected there. So C18 is one of the caps they want to change, and it's gone from 68 to 100. So let's find C68. No, let's not. Let's find C18. Find the thing. Difficult to see where it is. C18. It says 17. Oh, this C18 just down here. This tubular capacitor. Can you see this little tiny tubular capacitor down here? So that needs to pop that out. And these tubular capacitors are very old design. I mean, these were in radios in the 50s, you know, so God knows why they're still using these in the 80s, but let's try and get that out without damaging anything. One end out. Okay, that's the other end out. So that's C18. This is M750. Oh, it says 100 picofarads, so obviously this is a modification that's already been done, but it doesn't mean the capacitor is actually 100 picofarads, so let's have a look, see what it actually is. So I need you to see the LCR. Just in the camera so you can see something. There we go, this is the LCR just about from there. Okay, let's connect that up. So this should be 100 picofarad. Huh. Well, that's right, isn't it? So that's obviously clearly okay. That's at 1 kilohertz, I assume. This was like 100 kilohertz. Yeah, so that's good, isn't it? That's 100 picofarads. There's nothing wrong with that capacitor. So I really don't want to change a capacitor that checks okay. So I'm going to tick that off as a good one. And that was the sort of capacitor I was suspicious of. So I'm going to replace that. Put that back in. And hopefully go through some of the others and find something wrong. But I mean, those tubular capacitors are usually pretty reliable. Maybe I should concentrate more on these little red ceramics. They look like they're possibly the culprit. But certainly that capacitor tests fine. That's a good test for my LCR meter, my 4261 that I repaired. I'm glad that's working properly. So let's pop that back in. Require a bit of cleaning up and things. So I think what I'm going to do is it's going to be a bit of a laborious video of me with taking out capacitors, finding nothing wrong with them, putting them back in. I'm probably more interested in turning to another channel and watching some paint dry. So what I'm going to do is I'm going to pause the video, and once I find anything of any significance I'll come back. Thanks for watching. Okay, a bit of a disappointment really. What I've found is that all the suggested updates in the service manual here are actually the components installed, and all the capacitors I've measured so far, and that's most of the majority of the ceramics are absolutely perfectly in spec. So it's not that. One thing it may be is if you look at this trimmer capacitor here, this is the just show you that trimmer capacitor just here. You can see that. So we can get a bit of a zoom in on here. Nope, I don't think it's going to do it. You can see the crack in that capacitor. That's a trimming capacitor, and that's I think it's actually just an RF trimmer capacitor, and that capacitor is actually C3. And C3 is the trimming capacitor that's, sorry, C7. And it's this capacitor here, and it looks like it's on the like the front end of the RF. So I don't think that's anything to do with local oscillator. So I don't think that's going to be causing the problem. So I don't really know where to go. I'm going to go through and check a few more capacitors, but at the moment, most of the stuff looks okay. It's just odd why the response of the thing is so far out. I've certainly checked all the capacitors in series with the sort of local oscillator tank circuit and things, and they all look okay. It has got this varicap diode. This is a varicap diode here. Someone mentioned it, has it got a varicap diode, and I must admit I thought very much doubt it. But it does look like it has got a varicap diode, and there's a chance that that varicap diode is actually not working properly. And basically what a varicap diode is you apply voltage to it and it alters its capacitance. I'm trying to work out how this is actually working here, but it looks to me like it's not obvious how it's working to me, to be honest with you. But I would expect if it had failed totally, it would the radio wouldn't work at all. So I think I'm going to check a couple of resistors and then put it back together. But I mean, I've checked a couple of the capacitors and certainly there's no problem there. So I think, well, I don't really know what to think, to be honest with you. The scale calibration is clearly wrong. Maybe I'm barking up the wrong tree, but I'm going to check all the joints as well, make sure they're all soldered. But we'll do a few resistance checks and then we'll come back and maybe I'm just going to have to pull all the capacitors out and go through them all. But certainly the ones I've tested, they're absolutely fine. And the ones that are marked up 10 nanofarads are exactly 10 nanofarads according to my component tester. And it's the resistors I think to look at next. I've been messing around with this radio all evening trying to get the scale calibration better. I've checked all the components and all the updated components have already been fitted, so I'm sort of losing the will to live with it a bit really. I think the only true option would be to replace the FM module possibly with another one, may fix the problem. and I'm not even sure it's that. But what I have done is I've bent the fins on the local oscillator, which is quite a well-known trick for correcting for scale calibration. I've come up with quite a good result. Signal generator is generating 88 megahertz, and you can see here, pretty good. 96 meg. A little bit out, but not bad. And 108 meg. A bit short. 107.5. But miles better than it was, and probably acceptable really for a radio like this. So I think that's basically it for this radio. I might keep an eye out for a FM module. If I can find one of those, I might just transplant it and see if that fixes the problem. I went through all the capacitors. They all look fine. There's a couple of resistors that are slightly out of spec, but they weren't hugely out of spec, and I can't really see that making a lot of difference to the resonance circuit of the unit. It has got a varicap diode, and I'm wondering if that's a problem. Could be a sort of like the diodes become lazy or the capacitors become lazy. I don't know if they change with age. I don't know if it's sort of like a substandard part. But it's working pretty well. I've just got to do an FM alignment on it again to try and get the front end a bit more sensitive, and I think basically it will be calling it a wrap.